This is Mr. Bowman, and I want to show you some examples now of how to test a function algebraically to tell whether it's even, odd, or neither. Algebraically means not by looking at the graph or by looking at a table of values, but by looking at the function and its structure and its rule. So we want to determine if this function f of x equals negative x plus x cubed is even, odd, or neither. So let me kind of test each one. Let me test even first of all. So the test for even will be to replace x with negative x. So essentially what I'm going to do is I'm going to find f of negative x. And to find f of negative x, I'm going to replace each input, each x, with negative x. And I'm going to make sure everything about the rule itself stays the same, except for that change. So when I see negative x, I need negative the opposite of x. Plus, I need the opposite of x cubed. So to simplify this, the opposite of negative x is positive x. And then I'm going to add that to negative x cubed. You know, if I took negative x and multiplied it by itself 3 times, these two negatives here, or any two I pick, since multiplication is associative and commutative, would become positive. So what I really have is x times x, or x squared times negative x, and that's negative x cubed, isn't it? And another way to write x plus negative x cubed is to just write it as x minus x cubed. So this right here is the expression I need to look at. So we've got to answer 2 questions. Is that the same as the original function f of x? No, clearly not, right? The original function was negative x plus x cubed. This is x minus x cubed. So since the answer is no, it's not even. I'll also ask this question. Does it equal the exact opposite of f of x? Yeah, it does, doesn't it? Every term is the opposite sign of what we were given originally. I was given negative x, and now I have positive x. I was given positive x cubed, and now I have negative x cubed. Yes. What that means is that this is an odd function. If neither one of those tests had worked out to be a yes, then I would have said simply, it's neither even nor odd. Okay, this one's for you to try. I want you to hit pause and try this one. And when you think you've got it sorted out, hit play and get some feedback. Okay, let's test whether or not f of x equals x to the 4th minus 2x squared is even or odd, or it could be neither one. What I need to do is I need to find f of negative x. So I'll replace every x alone with negative x. I've got not x to the 4th power, but negative x to the 4th power. Minus 2 times not x squared, but negative x squared. Okay, negative x to the 4th power, and it's okay if you need to write this out. Maybe you don't need to determine this, and that's okay. But if you need to write it out, that's okay. Negative x to the 4th power, you know, these two here would become positive x squared, because 2 negatives multiplied make a positive. And the same is true here. This is just x to the 4th, isn't it? Then I have minus 2, and negative x squared would be just like this, wouldn't it? That would just be positive x squared. So there's my rule for f of negative x. So, does that equal the original function itself? Yeah, it does. Look. the exact same function rule. So what that tells me is that this function is even. I don't need to test oddness. It's not an odd function. Here's one more for you to try. Try it, hit pause, and when you think you've got it sorted out, hit play and we'll talk about it. If f of x is x squared minus x cubed, let's see if we can figure out what f of negative x is. So if I replace every x with negative x, I've got negative x squared minus negative x cubed. As we saw previously, negative x squared would be positive x squared because the two negatives would multiply to create a positive, minus negative x cubed, I think we saw would be the opposite of x cubed. Two of the negatives would multiply to become positive. The third negative sign would make the whole thing negative. And to simplify the opposite of a negative term makes the term positive. So the best simplified answer for f of negative x is x squared plus x cubed. So does that equal the original function itself exactly? Well, it's close, but no, right? We've got our x squareds, we've got our x cubes, but the sign between them is different. So that's a no, which means this thing is not an even function. Is it equal to the exact opposite of f of x? No. I mean, this term is the opposite of the original, x cubed and negative x cubed, but the x squareds are the same. So the answer to that question is also no, which means the function is not odd either. So if the function is not even and it's not odd, it's neither. It's neither even nor odd. And truthfully, a lot of functions are neither even nor odd. We saw that graphically earlier in this learning target when we were looking at the graphs of functions.